My name's Aditya, and the reason why I'm talking about the immune system is because it's the second most complex system in your body, and really your immune system is you. Every person's immune system is very unique to themselves, and you can see that oftentimes when people have different reactions to the same pathogen. Which a pathogen is basically any virus, bacteria, fungi, any invasive species that invade your body and causes damage to you. So the gut bacteria would not be pathogens because they're helpful to you rather than harmful, right? And you see, person A could be completely fine against COVID-19, but person B in the same age range could literally just straight up go and die in 5 days. Why is that? Well, your immune system is so complex and so influenced by genetic factors that even the smallest differences in genetic code can lead to completely different immune responses, even against the same virus. I'll go more into this and how specifically the lymphocyte system is marked by genetic codes. But first, let's talk about the defense lines. The initial defense line of your. Now let's imagine a nation. Let's call it Mama Land, okay? So Mama Land over here is a nation with a border, right? And it's got a border against like all of the, you know, bacteria, like barbarian nations around it that would love to get inside and, make their own houses inside her nation, but she doesn't want that. So what does Mama Land do? She builds a border wall. And this border wall in the body is your skin. Your skin is a very complex organ and the largest. It's a marvel in and of itself, evolutionary, and is constantly caused and is a conveyor belt of death. If you notice, every day hundreds of millions of skin cells die, rot, or fall off of you. A skin cell is born on the innermost layer of your epidermis, right? Which is the uppermost layer of your skin. Then, by the time it grows until it reaches the middle phase of your epidermis, then it kills itself. After that, it uses certain enzymes and proteins after it dies to harden and merge with the surrounding skin cells to form this tight and hard layer, which is your skin, right? And constantly these cells that have killed themselves are being shed off. It's one of the best examples of how your body sacrifices itself for you. Hundreds of thousands of cells dying just so that you do not get infected every other day. And this death sentence of a place is where your immune system starts. Since it's like a border, right? It stops enemies from entering. And since it's made from dead cells, it has a very low risk of getting infected. However, your skin is rather fragile, being just a couple layers of skin thick, of cell thick, right? And it's like for example, if you're while you're cooking, you cut yourself, right? That's a hole. And just like a hole in a border fence would lead to, spies and like terrorists and soldiers getting in, right? A hole in your skin leads to all of these bacteria, viruses, and such to enter your body. The second defense is the complement system, right? So imagine Mama Land again. Now imagine Mama Land has a very nice government that puts minefields just beyond its border. You know mines, those bombs that explode when you step on them, right? Those so if you take so like a mine is basically a bomb, right? If you step on it and then you walk off of it, it explodes automatically. It doesn't need any guidance or any instructions from the fighter, right? Now, the complement system is just a whole bunch of proteins that just circle in your blood. There's approximately 15 quintillion of them in your blood right now, which is a million plus a million. So that's like a million, 15 million proteins just circulating throughout your blood, your fluids, every fluid in your body. These proteins will just hang around there until they meet a pathogen. Like, say, example, there's a bacteria floating around and it wants to invade your home. Now, the complement system, now, no, now there's three ways that the complement system can activate by the antibody path, the lectin path, and the alternative path. The antibody path is started by antibodies, uh, you know, right? So basically, let's say a B cell has identified that there's a invader, so it attacks with the antibody. When this antibody latches onto the bacteria, it sends out like a chemical signal that causes all the nearby complement proteins to activate and attack the bacteria. The second way of activation is by the mannose binding lectin that is very common in attempting to stop viruses. And lastly, the alternative pathway is a little more random, but it doesn't need an immune response to start. So basically, there's a certain protein called C3, and it randomly starts to activate, right? And then it starts to seek out enemy. If it's neutralized, then it doesn't do anything. But if it attaches to a pathogen, then it starts a cascade that leads to, the death of the bacteria and the crippling of it. Now, just before I get into the rest of the immune system, Ravi, my mom has sent you a picture, has she not? Could you share that picture?
Yes, just a minute.
Thank you. So this picture, it states table two normal white blood cell distribution. Now you can see on there's two headings, white blood cell line and the normal percentage of total leukocyte. So to basically explain this, this is telling us what specific white blood cell we're talking about, and what percent of the total white blood cell population is that specific white blood cell. Example, neutrophils are part of your third line of defense, along with monocytes, eosinophils, and basophils. But lymphocytes would be part of your fourth line of defense. Now, neutrophils make up most of the population by being 40 to 60% of your white blood cell count. Lymphocytes make up 20 to 40%. Monocytes and macrophages make up 2 to 8%. Eosinophils make up 1 to 4%, and basophils make up 0.5. I will be explaining all of these white blood cells later, but this is a good thing you need in order to understand as we go forward. Now, first we start with the defense line three, which is the innate immune system. So imagine these soldiers are well equipped and they have gotten through your complement system or minefield, but with mine detectors. Don't worry, when that meteor smashed into the border wall to cause a wound, let's imagine that there was a wound caused by a meteor, right? A twig, for example, and so all of these border patrol soldiers will be like, oh my god, there's something clearly going on over there, and clearly something has happened, so we'll go over there and check it out. They see these terrorists, these soldiers just walking in, with their mine detectors, and they start to fire. Now these general purpose soldiers that fire indiscriminately are known as your neutrophils. Remember what I showed you, the first one that is 40 to 60%. Neutrophils are crazy killers. They absolutely love to kill. Their entire purpose is just to kill. In fact, they are so crazy that they are killed 3 days after they are born in order to protect the body from their maniac, right? But even though they're very dangerous, they're also very effective. As soon as they see a bacteria, they immediately go straight at the bacteria. They'll grab the bacteria, they'll rip it, they'll spew acid upon it or like enzymes, and they'll even explode themselves to erect barriers to not allow the what do you call it? The bacteria to go further in. Imagine like crazy soldiers that really would love to like kill and like explode themselves in order to create these patches where the enemy can't go through. That's basically a neutrophil. Along with them, there come the more advanced infantry patrol vehicles, right? These are more deadly. That is, they have like machine guns with them and are fitted with sensors so that they can detect what enemy they're dealing with. This is your macrophages and monocytes, which remember take up about 2 to 8% of your population. They are more effective, and a macrophage will be able to kill 100 pathogens before it like starts to get exhaust its lysosome reserves, which is lysosome is the acid that I was talking about that kills the pathogens. It also identifies the pathogen and either passes that information to a dendritic cell or goes to the lymphatic system to activate your next line of defense, which is your adaptive immune system. This is where the lymphocytes, which is 20 to 40%, those guys come in. Now, those guys, while they make up such a large portion of your body, of your leukocyte count, most of them are just sitting there, really doing nothing. Because see, the thing about unlike your innate immune system, which is a general purpose, I will kill anything that isn't part of the body type of mentality, the adaptive immune system is specifically designed for a specific pathogen. For example, if COVID infects a body, right? For example, then your measles B cells and T cells, your measles lymphocytes will not activate. Your COVID cells will activate, but your measles sites, your bubonic plague sites, they won't do anything, right? And while that may sound like it's a waste of time, remember these are inactive, so they're not really doing anything, so they don't take up resources, but they are very effective. So imagine in a body, it would be like the armed forces of your nation responding to an attack. So the Mama Armed Forces, or MAD for short, get involved, right? They take some time to act. So the army takes some time to activate, like bring their weapons out of stock, travel across the nation, and develop strategies. But when they arrive with tanks and artillery, right? So tanks will engage the enemy and rip them to shreds with the high caliber rounds, while artillery will kill thousands by simply just being there with thousands of shells and rockets impacting the battlefield, you know? So in your body, your lymphocytes are the mad forces, because they're hella mad that there's an invader. T cells are your tanks, ripping to thousands of pathogens to shreds from up close. While B cells are your artillery that's producing hundreds of little shells known as antibodies. You've heard of antibodies, haven't you? And these antibodies act like little guided missiles that strike pathogens to mark them for destruction or to, as I've stated before, cause complement cascades, similar to how like a rocket would impact the ground next to a couple of bacteria, only to cause the mines below it to explode. They take time to be activated by dendritic cells and macrophages, and they have to leave the lymphatic system first, which is a whole like highway of sorts for your body's adaptive immune system. Your adaptive immune system, a cell can be located here in your lymphatic system, and the site of infection could be on your other hand, and it could travel all the way within a couple of days, which for a tiny cell, a couple micrometers in diameter, is like traveling across a country within a couple of days, right? So they're extremely powerful, the system. And your thyroid actually plays a critical role in the adaptive immune system. See, the formation of a new T cell is basically that they switch up their genetic code in order to identify different protein, right? And then when it identifies a certain protein, it has to go through a certain trial where it has to, like touch many different proteins that are native to your body, right? Is Miss Monster talking? Um, and these And if it ever like decides that it wants to attack one of the proteins, then your body knows that this T cell or B cell is dangerous to the body and could cause harm. And hence and then they kill the what do you call it? The T cell that has been created. In fact, 90% of the new T cells that are created are killed off because they exhibit the wrong genetic code. Now, you have a fever, right? What is a fever? Everyone says fevers are bad, right? But are they really that bad? Well, if a sizable, imagine a nation that has sizable amounts of terrorists, soldiers, and spies make it in before the fences close. Then Mama Land would be at war. War is very straining on the country. To prepare, the country switches to war production. That is, factories that were making toys before now start to make guns and tanks and artillery, right? And more factories are forced to make guns and stuff. And this puts a lot of strain on the country and they're unable to trade with other countries, right? This is the same thing that happens in your body. A fever is this strain on you. The hotter temperatures are a reaction by your body because they cause cells to work faster and harder to produce the cells and proteins that you have lost while fighting the infection, right? But they also eat through your own stored resources. So all of that glucose, that fat you have stored, now it's suddenly being used to increase the temperature. Since how does your body increase the temperature? It increases the temperature by making your cells work harder. When your cells make energy, they actually really just start to burn their glucose with oxygen to form carbon dioxide and glucose. This burning causes the heat to come out of the mitochondria. So in order to increase the temperature, you have to just make more ATP, which means to put your cells into overdrive. Energy from digestion, which is similar to trade of a country, is going to be redirected to war. So you feel less hungry and you lose your appetite, right? There are more contingency plans, but these are either very complicated or they're not as common or more like latch ditch efforts that are extremely dangerous for your body. One such extremely dangerous effort by your body would be the cytokine storm. Ooh, ominous. Anyway, so imagine a nation that has had too much damage. The invading army has covered half of the country, right? Because of this damage, cities near that have been affected by the fighting, they will scream out, right? Like people are getting buried, hundreds of people are dying, the families of the victims will cry and scream, and this all is on video and being uploaded to the internet, right? And this like causes other cities to maintain high alert because there's fighting going on near them. This also causes many hundreds of people to enlist into the army. Like, I want to protect my country. Look at all these poor people that are crying and dying, right? I don't want that to happen. So I'll enlist in the army to fight. And it also forces like state governments to put in curfews and martial law. Your body also has such screens. They're called cytokines. When the screaming gets too loud or like gets too fanatic, then soldiers go on bloodthirsty rampages to kill every foe. The government's orders scorched earth tactics, and the country will fall apart due to distaste in how the country is handling the current, crisis. Your body has cytokines, right, which are very important hormones that are released by cells. They help to inform your body that something is going down, and clearly they have to, you know, do something. So when your cells are damaged or they sense that others have been damaged or there's toxic material around them, then they release cytokines. These cause cells to stop replicating, which is to prevent viruses from making more of themselves. They make your immune system more aggressive and they increase interferon production. However, the body has failed to stop the invasion, and large sections of say your body are now infected and are dying. Right now, your so many cells are producing cytokines that they slam into that the immune system basically goes into overdrive. It starts to the immune cells will start killing everything they see. Like neutrophils will start exploding everywhere, which often kills many healthy cells. And the body causes so much damage to itself through the cytokine storm in a last-ditch effort that it kills itself. Most of the deaths that you see from pathogens like the COVID-19, for example, are a result of such an overreaction. So when you see someone has died from COVID-19, in reality, they more likely died because their immune system overreacted and just killed itself in the process, which is shows why the immune system has so many switches in order and counteract. Because if it goes insane, the body is dead. Now, there are different pathogens, and different pathogens require different strategies. Simple, right? A simple logic. If you have a different types of enemies, you need to have different strategies to counter them. So bacteria and funguses elicit what people consider the normal response from your immune system. Initially, a wound causes bacteria or fungi to enter. Neutrophils and macrophages immediately start beating them up, your border patrol. And dendritic cells search for antibacterial T cells and B cells, ones that are specific to the bacteria in question. Complement proteins rip the bacteria to pieces and help the immune cells to capture the slippery bacteria, since bacteria do not want to die, and hence they evolve certain mechanisms in order to escape from immune cells. And these complement proteins simply help the immune cells in order to capture the bacteria. A couple days later, and lymphocytes will appear en masse. These antibacterial T cells and B cells start to kill off bacteria by the thousands and release hundreds of antibodies to ensure that you remain that clear the infection. After which, if many of your T cells will commit suicide, and many of your the extra neutrophils that were produced due to the infection also commit suicide, because once you no longer need the soldiers, they take up a lot of space and food, right? So like, what do you call? You discharge them from service rather than just keep them. Same thing happens, except instead of discharging a cell, you just kill it, right? And some of the T cells and B cells will remain as memory T cells and memory B cells. These are responsible for being your immunity. That is, they constantly search the surroundings for the specific bacteria or virus that you just fought in order to kill it whenever it arrives ever again. Okay? Now, funguses are also similar, but they need a little more aggressive nature because they're more like plants that have dug their roots into your flesh rather than a bacteria, right? Things get interesting though when you consider viruses, as neutrophils become less effective, and hence 60% of your immune population is sort of useless against this particular pathogen, right? As neutrophils are more of like a destroy stuff that I can see rather than a destroy stuff that's hiding inside of my friends sort of type, right? So the complement system truly shines in this area because the complement system, as I've stated before, can cripple viruses. However, since the viruses are much less complex than bacteria, they can't really rip holes into them. What they can do is through the lectin pathway, they can stop the viruses from being able to infect any other cell. And this makes them useless because a virus outside of a cell is just simply a dust particle. It's just a dust particle. It's just a piece of fat with a bunch of DNA, RNA inside. That's it. Inside the infected cell, it's amazing. It's doing everything, right? But outside, it's just useless. And that's when it's completely, and that's when viruses actually evolve to the first evolution to defeat the immune system is to stop the complement system. Example, the vaccinia virus, when it infects a cell, forces the cell to produce certain proteins that inhibit the complement, that is deactivated, which makes sort of safe zones around that infected cell, which increases the likelihood of that virus infecting more cells, which is why it's so deadly, right? Or more like, what do you call it? successful than other viruses. Now, if a cell detects that they have been infected, then they release hormones called interferons, which, as the name suggests, interfere with the virus's ability to propagate. These interferons, like cytokines, stop cellular activity in surrounding cells, which viruses depend on, and make the immune system a lot more aggressive and cause the immune system to. Miss Manasa, do you have a question?
No, I have something to add and appreciate you. Thank you. Can I?
Oh, okay,
Yeah.
sure.
So yes, it is actually an amazing topic because the way that through the depth that you're letting us in, you for us for you are making us understand is very well, because understanding the immune system is something which is a very very vast topic in itself. We understand because there's a lot of study, PhDs, there's a lot of research that's going on, and today's topic was also, I think this is a point where we can surely ask others what they've understood and how we can improve our immune system via the system here, because
Okay,
you have.
have two more slides to go through explaining two other pathogens that you have to deal with. And these are actually very interesting, right? So I'll just quickly do these and then we can go on to to checking everyone's understanding of our knowledge, right? And how to make your immune system better. Now, you know what you know cancer, right? It's the deadliest cause of death in the world, right? And what is and tumors are very similar to viruses in that they're the bad guys, and the infection, like the bad stuff, is basically your own cells that have been corrupted. During every cellular division, that is when one cell becomes two cells, your body makes around 120,000 mistakes, which is very awesome because that's out of 6 billion bases pairs, or actually 12 billion bases, which are copied every cellular division. That is pretty impressive for a bunch of atoms that are folded into a fancy shape. However, one of those mistakes will cause the cell to uncontrollably divide and become rather selfish in that it takes nutrients for itself and doesn't really put a stop on how much nutrients it takes. This is your cancer cell. Hundreds of these cells are created and killed by your immune system every day. In fact, you'll probably have a cancer cell that's been killed right now as you've been watching this. But if a very advanced evolutionary lineage of cancer survives multiple immune system attacks, then it evolves the ability to paralyze your immune system. Remember how I told that the immune system was a very dangerous system? Well, it has a bunch of chemical receptors on most immune cells that, when activated, prevent the immune cells from, say, attacking. This is important because, say, if this is needed by neurons, for example. Your central nervous system is a very delicate system with like not even they're touching. It's like they're just barely like together and they're like just like this, right? They're just like this. There's a synaptic gap, right? And any immune cell can just come over here and just rip them to shreds, these connections, which can cause a whole bunch of brain damage, right? This is the reason why your neurons have the ability to shut off immune cells at any point. However, cancer takes hold of this issue of this evolutionary detail and just starts stopping every single immune cell that comes their way. And this inhibits the immune response and allows the immune system to fully no allows the cancer to start spreading rapidly. This is the origin of a fatal tumor, right? And since cancer is your own cells, your body needs special cells like killer T cells and natural killer cells in order to deal with them. And your average neutrophil won't be able to do nothing against them. And since modern medicine can't really differentiate between cancer and healthy cells, most cancer treatment is either just killing everything in the area, like a mass bombardment. Chemotherapy is literally just killing all of the cells in that area. That's why when you do chemotherapy, you lose your hair because your healthy hair cells are being killed off, right? Or just boosting the immune system. That's the newest side of cancer therapy, which is immunotherapy. And finally, the last thing is parasites and allergens. In parasites, you can forget your immune system. 90% of it won't do anything, right? Parasites, parasites are like those worms that you get in your stomach. You know those worms, right? Those things are parasites. And allergens are basically when you inhale. So some people, when they eat peanuts, they die, right? Those are also allergens. These when they get into your body, they are extremely complex multicellular organisms with a skin layer and a whole bunch of layers, and just like you, in order to stop any invasion. So you need a special cell. Now remember when we went back, there was two other cells in that list, right? We had the neutrophils, then the lymphocytes, and the monocytes, or right? And then we had two others, which were eosinophils and basophils. Finally, these people that we forgot about, it's time for them to shine. These are the things that deal with your parasites and your immune cells, They're so forgettable that when writing the presentation that I'm referring to, I forgot their names and had to search them up, right? But these are very important and they constantly circulate throughout your system. Any virus that comes in, eosinophils will latch onto them, make a hole, and just throw every single bit of their organic material inside in order to kill that parasite. And all of this protection of your gut system is due to these tiny, tiny cells we call eosinophils and also basophils, which initiate the immune response. So be sure to thank these two cells that no one remembers, and please do not forget them. Thank you.
Oh my God. Now, this was a view or a session where I felt that we have heard and learned from a person. I mean, a very scientific topic, right? Anas Lelva. Yes, we did, and to the depth that he made us go through, and the examples that he gave us was very. It was in a very is a very good way where we could understand maybe the tanker examples, the Mama Land examples, and the way that we have been bombarded. Everything we were able to understand, and thanks a lot, Adi. So people, I mean, everyone would love to appreciate him. Okay, can we all thank him for the session that he has taken here to let us understand the complexity of immune system and how important it is for us to manage our immune system better.
I
Thank,
like the topic that he spoke and was interesting. But it was similar to my wife's discussion where I don't understand much on medical topics. But I like his the way he has spent his time on exploring the subject and speaking at a length for such a long time. Quite impressive. Thanks, Aditya, for this session. And I think so. You should be a regular person in our forum at least once a week so that we can get all this knowledge from you. Thank you.
thank you. See, Aditya, what you have done is now Vinayak has not given a response to any one of us here, and he's come up and given you a response that shows the impact of your session. Congratulations, bro. You're amazing. So yes, Rajeshwari, over to you.
Congratulations, Adi. Like you have spoken so much. You were correct. So much of information and about the immune system. You have spoken so many things like brain damage. So many things. Like I love the way you expressed your all your thoughts and the way you explain it in detail with the examples. It was superb. Thank you for coming to the system.
Thank you. Yes, exactly. Over to you, Prabhat.
I think he is a big competitor to my profession, teaching profession. I think if he comes there. Very well done, Aditya. I actually like your narration. I feel like ಒಂಥರ ಯಾರೋ ಒಬ್ರು ಪೋಸ್ಟ್ ಡಾಕ್ ರಿಸರ್ಚ್ ಮಾಡಿದವ್ರು ಕೂತು ಹೇಳ್ತಾ ಇರೋ ಹಂಗಿತ್ತು ನನಗೆ. I really like, and I want this kind of depth in our understanding and also presenting. Very nicely presented. And two, three things that I wanted to add is how we develop that autoimmune system and how we suffer. And this is something, remember, this is the extreme situation. When whatever we do is goes to that extreme, even body gives up that and at that extreme situation. And we should never lead to ourselves to that condition and stay within the controllable limits and manage our parameters. That's one of the things that I wanted to add. However simplified, it's a big topic and cannot be put into half an hour slot like we do, right? Okay, very
Yeah.
well done. Congratulations, Sada. You are bringing a big, orator into our community. Very nice. Thank you.
Yeah. Actually, he has so much information